Find the number of ways of arranging 6 men and 2 boys in a row if there are exactly 2 men separating the boys. In this kind of question, where you have 6 people, 2 people, whatever, as long as people, it is assumed to be all different, yeah, all different. The boys are distinguishable. They can't be 2 identical. Even if they're twins, they are distinguishable. So there are 6 different men, 2 different boys. The way to look at it is we like to number them like that, M1, M2, M3, M4, M5, M6 to be clearer, and then B1, B2. And you are exactly 2 men separating the boys. So can we use this diagram to illustrate? Let's say you have B1 space B2, or B1 space B2, and on and on. So the technique that we want to use is to group them as a unit like that, right? Group them as a unit. But after that, in between the 2 boys, you need to choose. You need to choose which 2 men will go in. So it is broken down like that, which 2 to go in. Simple, out of the 6, I permute 2 because it is. Again, some of us may want to choose it as 6 times 5. I'm perfectly fine as well. But if you want to be consistent, you can just use 6p5. Number of ways that you can permute 2 out of 6 different objects. So after that, your B1, B2 may not be in this order. It could be B2, B1. So you multiply by 2 factorial. Right? Then after that, you will have your one big unit, and then to arrange with 2, 3, 4, 5 units. So actually, you have 5 units to arrange. I say why 5? Because after the 2 are in, this 2 goes in, you are left with 4 others. So therefore, times 5 factorial. So total number of ways, you use the multiplication principle, you get a 6p2. That's when you want to permute the 2 men inside between the 2 boys, 2 factorial to permute the 2 boys, and then 5 factorial because you have 5 units to be arranged. Next, part B, you want at least 2 men separating the boys. At least 2. That means it can be 2, it can be 3, it can be 4. The most intuitive thing many people will do it is you consider cases, right? It can be 2 separating the boys, 3 men separating the boys, 4 men separating the boys, and on and on and on. And it could be even 6 men separating the boys. So there are actually, if you look at it, it's 1, 2, 3, 4, 5 different cases. To me, it is too many cases. 5 cases. It's bad because it's time consuming. I would like to present another method, alright, which is the complement method. What do we mean by complement method? This is all the cases that we want, but the complement is actually 1 man separating the boys and 0 men separating the boys. These 2 are actually the complement of this group. Make sense? And you want so the way to do it is to take the total number of cases minus away these 2 cases. Now what are these 2 cases then? Alright, let's practice. Right? To get 1 man between the boy, yes, it is to choose 6p1 because you want to choose that man inside here, times 2 factorial because the b1 and the b2 can swap, times 6 factorial because you now left with 1 unit, 2, 3, 4, 5, 6 units to permute. Now, no man separating the boys is easy. We go through it very, very quickly. 7 factorial because there is 1 group, 2 group, 3 group, 4 group, 5 group, 6 group, 7 groups in that sense, times 2 factorial because the b1 and b2 can swap. So, therefore, final answer must be the total number of ways without any restriction. Basically, it is these 8 people arranged together. So, must be 8 factorial. Minus away the 2 complement cases. Then you will get your final answer. Thank you.